we're going to have a look at the general principles of electrolysis. So let's start at the beginning, what we're going to need and how we're going to set it up. So firstly, we'll have a beaker, and it doesn't really matter what the beaker is made up of, as it won't be forming part of my electrolysis. Now I'm going to fill my beaker with an electrolyte. Now my electrolyte, which can be either a molten solution or an aqueous solution, must be made up of ionic compounds. This is because covalent compounds do not conduct electricity, so they cannot undergo electrolysis. Neither can solid ionic compounds, as they have no free ions that can move and carry the charge. So my electrolyte will then dissociate into its positive ions and its negative ions in my electrolyte. I'm then going to need 2 electrodes. Now these electrodes are usually made up of metal or graphite that can conduct electricity into or out of our electrolyte. Now they are then connected to my power source. Now my power source will have a positive as well as a negative pole. Now my positive pole will be connected to my positive electrode, and my positive electrode is called my anode. Then my negative pole will be connected to my negative electrode, and this is called my cathode. Now cations, which are positively charged ions, will be attracted to my cathode. Now these ions are usually metal or hydrogen gas that will form at the cathode. Now anions, so negative ions in my electrolyte, will be attracted to my anode, which is the positive electrode. Now these anions are non-metals, except they cannot be hydrogen, and they will form on the anode. Now the reaction that occurs at my cathode, meaning the metal or the hydrogen that needs to form at my cathode, all depends on the reactivity of that metal or hydrogen. Now if the metal is less reactive than hydrogen, like for instance copper and silver, then the metal is produced. But if the metal is more reactive than hydrogen, like sodium and magnesium, then hydrogen gas will be produced instead. Now the reaction at my anode, which is where a non-metal is formed at my anode, will depend on the concentration of my electrolyte. Now during electrolysis, current needs to flow around the circuit. Now in order for this to occur, charge must be transferred around the circuit. Now remember, current is a measure of the rate of flow of charge by the charge carriers. Now the power supply will provide the cathode with a supply of electrons. This will cause the cathode to become negatively charged. Now the positive ions, my cations, are attracted to this electrode and move towards the cathode where they gain the electrons. My negative ions, so my anions, will then be attracted to my anode where they will lose electrons. These electrons will then move from the anode back towards the power supply. So if we think about a complete circuit, electrons are the charge carriers in the external unit, and the ions are the charge carriers in the electrolyte. So let's quickly stop for a moment at our reactivity series. So we can arrange our reactivity series from most reactive to least reactive. Now remember, if the metal that is supposed to form is below hydrogen in the reactivity series, the less reactive metal ion is discharged. So the metal is produced, and this will be seen plated onto the cathode. Now my most reactive metal is potassium. Then I have sodium, then lithium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, and gold. So the only metals that are less reactive than hydrogen would be copper, silver, and gold. The rest of the metals are more reactive than hydrogen. So the first type of electrolysis that we're going to look at is those of molten compounds. So here we have, for example, a molten compound led to bromide. Now this is a good example of a binary ionic compound. Now this is one consisting of just two elements joined together by ionic bonding. Now when these compounds undergo electrolysis, they always produce their corresponding elements. So to predict the products made at each electrode, we first need to identify the ions. So the positive ion will migrate to the cathode and the negative ion will migrate to the anode. Therefore, we can say that the cathode product will always be the metal and the product form at the anode will always be the non-metal. So for this example, we used carbon electrodes, which are an example of an inert material. Now, inert refers to something that does not react easily. Now, because lead is my metal, it means that it would move towards my negative electrode, meaning my cathode. It will here gain electrons and form a gray lead metal, which will deposit on the surface of the electrode. Bromine is my non-metal, so it would be my negative ion, and it would be attracted to my positive electrode, or otherwise known as my anode. Now here, each bromine will lose an electron to form bromine molecules. So here we'll be able to observe bubbling, and we will be able to see brown gas being given off, which would be my bromine gas. Next, we can have a look at the electrolysis of aqueous compounds. Now, we need to remember that aqueous solutions always have water present. So in the electrolysis of aqueous solution, the water molecules will dissociate, producing hydrogen and hydroxide ions. Now these ions are also involved in the process and their chemistry must be considered. So we now have an electrolyte that contains ions from the compound plus ions from the water. So which ions gets discharged at which electrode will depend on the relative reactivity of the elements involved, as well as the concentration. So whether the concentration is concentrated or dilute. Now for the anions, the more concentrated ion will tend to get discharged over a more dilute ion. Now if we look at the example of the electrolysis of aqueous sodium chloride, we need to notice that they did not say dilute sodium chloride, but just aqueous. Now we're gonna electrolyze this electrolyte using inert carbon electrodes. So the ions that will be released is sodium, which is positively charged, as well as chloride, which is negatively charged. Then we also have hydrogen, which is positively charged, and hydroxide, which is negatively charged. So between my positive ions, I'm going to look at reactivity. And between my negative ions, I'm going to look at concentration. Now, sodium is more reactive than hydrogen. So a hydrogen gas will form at my negative electrode or my cathode. Then at my anode, because this is a concentrated solution, chlorine gas will form at this electrode. And the reason for this is because if the concentration was dilute, water would have formed. But it's not dilute, it is concentrated. Next, we can have a look at a dilute solution. And for this, we're going to look at dilute sulfuric acid. Now, dilute will be my water. So this would be positive hydrogen ions or negative hydroxide ions. Now my sulfuric acid will give me sulfate ions, which is negatively charged, also hydrogen ions, which is positively charged. Now for this one, we will also use our inert graphite electrodes. Now at my cathode, which is my negative electrode, hydrogen ions will be attracted. This is because it is the only positive ion that's present in my dilute sulfuric acid. Then at the positive electrode or my anode, hydroxide ions will be attracted to this electrode. This will then form oxygen gas and water, and this is because it's a dilute solution. Remember, if this was a concentrated solution, then my sulfate would have formed.